Good evening, everyone. We'll wait 2 to 3 minutes more to join all the participants. Hello, every good evening. We'll wait for 2 to 3 minutes more to join all the participants. Good evening, everyone. Welcome to today's webinar on Abaqus for Geotechnical Analysis. My name is Utkarsha Thakre, and I'm delighted to be your host for this insightful session. Thank you for taking the time to join us today. We are confident that today's session will provide you with valuable knowledge and practical insights. Before we dive into the main topic, I would like to introduce you to PIGSO Learning. I'll share my screen. Is it visible to everyone? The screen is visible, right?
Yes, it's visible.
Okay. So, so So PIGSO Learning specializes in providing engineering simulation, training, and project assistance, focusing on bridging the gap between theoretical knowledge and practical applications, enabling our clients to solve real-world challenges with confidence. PIGSO Learning was founded by Mayank Panchal, driven by his passion for accessible and high-quality engineering education, recognizing the need for practical, hands on training that extends beyond theoretical knowledge, and that is the vision what drives us today. Our services focuses on industry 4.0 softwares. We have we provide software training, project assistance, and customized solution also. In software training, like this program is based on industry standard software like Abacus, ANSYS, Plaxis, SolidWorks, and much more. We offer both live online courses and self-paced learning options also. We provide project assistance. We support for your engineering research projects from initial concept to final validation. We provide expert guidance on modeling, simulation, and analysis. PIGSO Learning offers customized solution designed to meet the unique needs of organization and research scholars. Now, it's my pleasure to introduce our speaker for today, Dr. Vaibhav Mittal, a leading expert in finite elements and shake table investigations. He is highly experienced engineer and a dedicated educator at PIGSO Learning. He has extensive experience in geotechnical engineering and a deep understanding of Abaqus simulation. His expertise include geotechnical earthwork engineering, seismic soil foundations, and structure interaction of building. We are fortunate to have him leading today's session. Dr. Vaibhav Mittal, I hand it over to you.
Thank you, Utkarsha. Uh,
Thank you.
Audible now?
Yes, you are.
Okay. So first of all, I'm thankful to the PIGSO Learning
Mhm.
for organizing this webinar. And in this webinar, basically, we are going to learn regarding the uses of Abacus basically on soil structure interaction. So for that, I will start sharing my screen first. We share now. I think my screen is visible. Just confirm once.
Yes, it's visible.
Sure. Okay. So myself, Dr. Vaibhav Mittal, as introduced by Utkarsha. So today I'm going to give a webinar on basically on how to do an Abacus numerical modeling on seismic soil foundation structure interaction of buildings basically, and this is basically on pile foundation basically we have taken, and this is one of the course basically which I am taking. This is basically a live training program which is currently running also. So in this one we are going with Abacus geotechnical analysis training, in which both basics and advanced training program has been provided. directly from my side. In this one, we are providing different details like how to do a foundation modeling, how to do contact interface, how to do advanced modeling also like tunneling and your geosynthetics. And also we are also included in this training program. We have also included the use of user-defined model also. Like if people wants to develop their own soil model and then they want to do the analysis in software, then how to do that one also. So that also is being covered. So if anyone wants to enrolled into this program, they can contact on this email ID or on this contact number. Now, moving forward to the today's webinar, this is the introduction which is already been given from the Utkarsha. So I will move forward, and so the outline of this today's program is, so first of all, why this soil foundation and structure interaction is required. That is first point. Why this is why it is required, and what are the different techniques to solve this problem. Then how Abacus will help in this one, and how we are doing these different modelings and all, so that we will discuss. And then how the results are obtained basically from the numerical modeling, that is Abacus, that we will discuss, and the conclusions and relative publications from this work is also being given in the presentation. So moving forward, what is the motivation behind this study? This study is basically the part of my PhD work, which I have done during my PhD work from Central Building Research Institute, Roorkee. So as you know, now currently what is happening, that that population is increasing and there is heavy urbanization. So due to increase in industrialization, there is very lesser space are available. So due to unavailability of space, now constructions are being done over the soil which is not suitable, means whose bearing capacity is low. And one of the basic term which we generally use during earthquake studies, shear wave velocity. So if that the shear wave velocity of the soil is under that criteria, like if I am going with the classification of soil as per ASC guideline, so we are constructing the soil over the stratums which are under the classification of D and E types, basically soft soil conditions which are not suitable for constructions. So generally, from past earthquake experiences, it has been observed that non-consideration of this soil structure interaction can lead to damages. Why these damages are obtained? There are several reasons behind that one. Like you can see in the slides, this damages like this piles has been failed during the San Francisco earthquake. Then similarly, during Alaska earthquake, during Niigata earthquake. In all these cases, due to non-consideration of SSI, the damages has occurred. Like in this one, if you will see in Mexican City earthquake, especially if you will see, there are basically two different types of foundation are being used in Mexico, from where basically this SSI was more pronounced or more considered, or more basically we are going on this research, because during Mexican City earthquake it was observed that there were several buildings which are supported on pile foundations, and as we know, pile foundations can be end socketed ones, and it can be floating pile also. So it was observed that the buildings which were supported on floating pile, they got more damage in comparison to the end socketed one. So what we observed, that the foundation which is basically supporting the structure is influencing its seismic response. So that is why we should consider the effect of SSI. That is the major objective for this webinar or this research on SSI. That generally what we are doing, this which can be understood from the upcoming slides. Another common example, if people are working on this SSI, is this Kobe earthquake Hashin expressway failure. It was observed that due to period lengthening, because here the this foundation flexibility came into picture, because foundation was not able to follow the free field response. So what it leads to the collapse of this period lengthening. Period lengthening means here resonance occurred, resulting in the collapse of this Hashin expressway. A few part of the Hashin expressway was collapsed during the Kobe earthquake. Similar observations were observed during the Nepal earthquake of 2015 also, that due to non-consideration of foundation effects, these buildings were collapsed. Now, basically, what is basically this exercise? So far, I was talking regarding the experiences we have seen from the previous earthquakes. So what we basically used to do, like what we are basically doing. So this is the conventional approach which we used to follow. So whenever we are designing any structure, what we used to do, we should design the structure by assuming it as a rigid condition. Means we are considering it as a rigid base. But in actual condition, does this one and this one are they same? No, they are not same, because the available soil condition, the foundation system, the stiffness of this two body are different, completely different from the rocky strata. So suppose an earthquake is coming in this case, and if an earthquake is coming in this case, then the response of our structure will be completely different in comparison to the other one. This performance of the building is basically obtained on the basis of FEMA code. So what FEMA code says that the performance level of a building can be specified on the basis of your qualitative level and quantitative level also. So how they have uh, described the performance level quantitatively is the term they have given is interstory drift. They are saying that if the interstory drift, they have given certain values. So on those values, we can decide whether your building is safe or it is not safe. So for that, they have given 5 performance levels: occupational levels, fully occupational levels, then life safe limit, collapse, and nearly collapse condition. So it is observed that as per the code, it has been said that if the interstory drift of the building is crossing 1.5%, then it is said to be under life safe limit. And if it is crossing more than 2.5%, it is under collapse condition. It is under collapse condition. So basically, this regarding this one, this can be understood from this next slide also more proper. So now, basically, what is soil foundation structure interaction? Now, see, suppose I'm taking an earthquake. So here a point A has been considered. This is basically a rocky strata. So what will happen if suppose a soil is there over the top? So if soil is there and if suppose an earthquake is coming in this picture, if an earthquake is there, so what will happen? These arrows are basically showing the amplitude. So depending on the characteristics of the soil, what will happen? Because in this case, the stiffness of rock is very high. So if stiffness of rock is very high, it will not leads to production of development of transverse shear and overturning moment. That is why the building response are found to be safe. But as soon as soil will come into picture, then in those cases, what will happen? So in this case, what will happen? Now, depending on the frequency content and characteristics of the soil, amplification may occur. Now suppose we are doing an excavation here. Now, if suppose I am doing an excavation here, basically for foundation system. So as soon as you are doing excavation, now what will happen? Just picturize this one in your mind. That suppose your foundation is there. Now what will happen? The soil will try to do certain response. That response is basically free field response. So soil will try to follow a free field response. But due to the stiffness of foundation, it may not follow this free field response. So the inability of the foundation to follow, so that it cannot follow the free field response, is known as kinematic interaction. And once we are considering the inertial effect of the structure and foundation, then what will happen? Now what you see, now what will happen now? Just try to picturize now. In this case, the stiffness was very high. Now the stiffness of the system is very low. Since the stiffness of the system is very low, a transverse shear and an overturning moment will develop. Now, due to development of this transverse shear and overturning moment, the lateral displacement of the building, which we are saying, suppose it was x in value, now it will have increased. So this type of interaction is known as inertial interaction. So basically, these two interaction, kinematic interaction and inertial interactions, are two types of soil foundation structure interaction. So what is soil foundation structure interaction? The phenomena in which the response of soil affects the motion of structure and vice versa is known as soil foundation structure interaction. This can be understood from the slide also, that animated slide we have made. So suppose this is your structure, that is rigid base, and this is on a compliant base, that is basically over a soil medium. And suppose I am saying we are taking this earthquake of similar intensity, similar data, means all the data are same. And if it is incident on this structure and on this, the structural characteristics are also same, just it is resting on a rigid strata and it is resting on a soil data or on a soil stratum. The results shown here are just an imaginary figures, just to make you understand that how SSI will influence your result that I want to show from the slide. So what you can see here, that the deformation of the building in this case was very less, but here in this case the deformation of the building has increased significantly. Why this is caused? Because due to development of overturning moment, this foundation will rock. So rocking of foundation is basically playing an important role in the means in the increment of lateral displacement of the building. So what are the several parameters which are affecting this response? First is the foundation. under the available site condition, the configuration of structure, because this is regular structure. If suppose irregularity is there in the building, again SSI will be more in nature. And under is input ground motion. So there are several other parameters like local side effect. If I'm talking the single point, that is local side effect is playing an important role in influencing the seismic response of the system. That is basically your structure and foundation. Now coming to the codal provisions. So basically what, if I'm talking regarding the Indian code, so what Indian code is saying, that IS 1893/2016 code, what it is saying, as per clause 7, it is saying that SSI may not be considered for structures supported on rock or rock-like material under any earthquake disturbances. So for this consideration, they have given a time period equation, that T is equal to, for a moment resting frame building, that is RCC building, that T is equal to 0.075 h raised to the power 3/4. This is the equation which is being given by IS code. But as we know, India is a developing country, and there is very, due to increase in population and urbanization, now we everywhere we won't get a rock like condition. So we need to construct a structure where soil is there. So how we will consider, because we are designing, which can be understood in the next slide. We will see basically what generally we should do, that I will show first in that slide only, then I will come to this slide. So see, this is basically the first approach, that is basically the an structural engineer used to do. What a structural engineer will do, he will design the structure assuming as a fixed base depending on different loadal combination. And what he will do now, what a geotechnical person will do, he will consider this one as a lumped mass approach, and depending on these reactions, that unfactored load which is obtained from the column reactions, we will design the foundation. But in actual condition, this is not a single system. This is not a single system. These two are basically combined in actual condition. So what will happen? That is basically, it is being shown in this diagram, that this is, in this one what we are doing, we are not considering the effect of the system. In this one, we are not considering the effect of structure. We are basically using lumped mass approach. But in actual condition, this is a coupled system. So whenever earthquake will come, what will happen? If suppose an earthquake is coming, foundation will deform, and depending on the foundation deformation, your structural deformation will also change. So you can see, in case of fixed base stratum, this is the lateral displacement, that is denoted by small s. But depending on the foundation type, that is, if suppose your pile is a rigid pile, or it is an intermediate pile, or elastic long pile, your response of the system will completely change. And you can see the total lateral displacement has increased. So it will have two components. One will be due to the rocking, because this foundation will rotate. So due to the rocking of foundation, one phenomenon will occur. Another is this translational component. So these two will lead to a total lateral displacement, and it is observed that this would be larger than this one. So just try to picturize this one. Now suppose this is a single structure. Now suppose if I am designing a structure corresponding to this lateral displacement, and suppose another structure is there adjacent to this one, then what may happen, that it may cause pounding effect. It may affect the surrounding structures also, and it may also affect its own performance also. So that is why we should consider the effect of soil foundation structure interaction. Means instead of designing this structure and foundation separately, we should develop a methodology where we should use the coupled analysis. So that is the importance of SSI over rigid stratum. Now coming to the previous slides which I was mentioning previously. So Indian code is basically silent about all these things. Although in the new code, which is the drafted code which is given, they have given certain guidelines, but still there are several things which needs to be considered. Another code, that is ASC 716, which is basically talking regarding SSI. Few of the points they have considered, like they are mentioning that where we should consider the effect of SSI. They are also given few of the methods, but still, because if suppose a building is supported on isolated footing, and if it is supported on a raft footing, if it is supported on a pile foundation, if it is supported on a pile of foundation, so depending on foundation type, your performance of structure will also change. So how the foundation will affect your structural response, so that is not being considered in ASCE code. So this was the reason why I conducted this research using experimental investigation and numerical investigation, that is Abaqus. So what are the solution to the soil foundation structure interaction problem? So there are two methods, that is experimental method and computational method. So basically in today's class, we are going with this computational method, that is also direct approach. So we will go to the direct approach. what is basically direct approach? In direct approach, what we used to do, now in actual condition, soil is wide, soil is an infinite media. But whenever we are doing a modeling in Abaqus or any finite element software, we are using a finite media. So, so what we will do in direct approach, we will construct this structure, foundation, and soil in a single system. However, in case of substructure approach, what we used to, there are two approaches: direct approach and substructure approach for a SFSI problem. In substructure approach, instead of modeling this complete system in a single body, this I will discuss in more details in the upcoming slides. That is why I have discussed very small about this one, because this is the aim of this today's webinar. So this we will discuss in upcoming slides in more details also. In substructure approach, what we are doing, this is my complete solution. So first of all, what I will do in first approach, what I will do, I will not consider the mass and structural, sorry, mass of the foundation and structure. Just what I will do, I will just follow the kinematic interaction. Means I will try to find the foundation input motion. And once this foundation input motion has been obtained, then in second step, what I will do, I will try to find the impedance functions. And these impedance functions and these foundation input motions are applied at the base of the structure to obtain the seismic performance. So this is the substructure approach. Now, if suppose people can ask which approach is better. So if you are following a direct approach, the computational time will be more. If you are following substructure approach, computational time will be less. But again, in this case, we are basically not, although we are using this kinematic interaction and this subgrid, means foundation input motion and impedance function at the bottom of the structure, still we are missing the foundation because there are shadowing effects, there are foundation, how they will interact. So these all things we are not considering in substructure approach. That is why that approach is generally vastly considered for the solution of SFSI problems. So this I have already discussed. So now moving to the Abaqus numerical modeling. So first of all, whenever you are doing any Abaqus modeling, any finite element modeling in Abaqus, whether it is a structural engineering problem, whether it is just your geotechnical problem, whatever problem you are going to do, Abaqus does not know which unit, like, because if you are going to enter anything, it will just give you the numerical value. It does not know what unit you are entering. So it is the user who should understand what unit we should follow. Like if suppose I am following SI units, so length should be in meters, force should be in newtons, mass should be in kilogram, time should be in seconds, stresses should be in newton per meter square, energy should be in joule, and density should be in kilogram per meter cube. Because the common habit of a geotechnical person is that for unit density generally we use the unit kilonewton per meter cube, but we should use kilogram per meter cube in Abaqus. If suppose you are modeling in mm, then your density should be in ton per mm cube, mass should be in tons, and stresses should be in megapascal. So these are the unit system which you should keep in mind whenever you are going to do any kind of modeling in Abaqus. So once you will open your Abaqus model, it will look like this one. So this is the toolbar. Here basically Abaqus has several features. In first one, that is basically a parts. So like today we are dealing with soil structure interaction problem. So there we are having several components. Like we are having superstructure, we are having your substructure, that is your substructure or foundation system. We are having soil also. So in parts, what we will do, we will create these ones separately. Then after that, we need to assign the properties, and then in this assembly module, we will assemble them completely, and then we need to follow the steps function. Steps means what kind of study you are going to do. Like suppose if you want to perform dynamic analysis, so you need to provide dynamic step. If you perform a static analysis, so you should define your steps here. And in field output request, we need to select the variables. Like I want displacement, so I will select U. If suppose I want acceleration, so I will select A. So whatever variables or whatever results I want, I will select this one in field output request and history output requests. Then in interaction, we will define the interaction, means the contact, because there is a foundation, there is a structure, and there is your soil. So what we need to do, we need to define the contact between the foundation, the soil, and the structure to simulate soil foundation and structure interaction problem in Abaqus. Then your next step is your loading. In loading, whatever different kinds of loads are there, that you need to assign. And then you need to assign your boundary conditions. Then we need to do the meshings. And once these all things have been done, we can run your analysis also. And after running the analysis, we will get your results. Now, we will move to the modeling part. So before moving to the modeling part, what are the different types of elements I have used for this today's webinar or for my soil structure interaction problem. So these are the 4 different types of elements. First one, this is 2-noded linear beam element. This is basically used for modeling of beams and columns. One more thing, in today's webinar, we are going to discuss regarding the modeling of a moment resting frame buildings. So in moment resting frame buildings, we are modeling the columns and beams using this beam element, and slabs are basically modeled using this cell element. Then foundation and soil are modeled using this your C3 data, that is continuum element. And another thing is that, as I mentioned initially, that in field condition, soil is basically your infinite media. So to simulate the infinite boundary condition, that is absorbing boundary condition, we have provided infinite element in the direction of shaking. So for that, I have used this infinite brick element. Another thing is that what is, you can see we are using different types of elements like reduced integration, hourglass control. These are different things which we should consider in Abaqus. So these details can be obtained in one of my paper, which is already published in Journal of Structural Design and Construction Practice. So you can see this paper and you can understand what is the usage of this reduced integration and hourglass control for modeling in Abaqus while doing any SSI problem. Now moving to the first part, at how a superstructure has been modeled. So in superstructure, how I need to model that one? So I will use 3 things. First is your beam, second is your column, another thing is your slab. So I need to model 3 things. So as I mentioned, that I am using beams and columns are modeled using 2-noded linear beam elements with 6 degrees of freedoms, while slabs are being discretized using quadrilateral cell elements with reduced integration. Another thing is that in this study, like whenever you are doing any superstructural modeling, what you need to do, you should provide certain properties. So you can provide your linear elastic properties, or you can also assign plastic properties. But in this study, I'm only providing the linear elastic properties only. But if someone wants to assign the plastic properties, then they can go with plastic properties in form of concrete damage plasticity. If they want to see how the damage is being occurred, so they can consider. Another important points whenever we are doing any exercise studies, the damping ratio. So as per this IS 1893 code and ASC 710, I have taken a damping value of 5%. So a structural damping of 5% has been taken, and depending on this study by Chaudhary and Dasgupta, so that is why we have taken a 5% this one damping. Another thing is that when we have modeled these beams and then these columns and this slab separately, what we need to do, we need to provide an interaction between them. So for that, what we are using a node to surface interaction between the column and slabs. And once we have done this, then we are getting a modeling like this one. So you can see these are linear elements. You can see these are the beam elements we have used for this your column, and similar for the beams. And then these slabs are being rested over this. So what we have done, so just try to imagine this thing. I will use a pen here to make you understand. So suppose this is your uh, suppose one frame, any frame. I am suppose I have taken one frame. So this is my frame, and I will change the one color also. And suppose this is a one, here's one slab is there. So basically what we have done, this we have taken the connections here. This interaction, one interaction we have provided here, that is between beams and columns. And then another interaction is there which we need to provide between, is we have provided between this surface, this one. That is the your so I will make this same color only. So the red color is basically your for your beams, and then the blue color is for your slab. So between this we have provided an interaction. So for that interaction, basically what we are following, we don't want a relative motion between them. So if you do not want any relative motion between them, then for that you should provide a tie constraint facility available in Abaqus. So we are using a tie constraint. This tie constraint is basically used when we are using tie constraint. This tie constraint is basically used if you do not want any relative motion between any different parts. So that is why we are providing the interaction between, that is node to surface. Another thing is that whenever you are doing any interaction, Abaqus will ask you 2 things, that is your master surface and slave surface. So how to assign, how we will decide that which will act as your master surface and which will act as your slave surface. So first criteria is, you can see the size. The one which is larger in size, you can use the master surface, and one which is in smaller in size, you can use as a slave surface. But like in this case, you can see both beams and column both are of nearly similar size. So in that case, what we need to do, we should see the stiffness. The component which is having larger stiffness, that will be assigned the master surface, and one which is the smaller stiffness, that we will assign as a slave surface. In other words, we can see a rigid body will act as a rigid body will act as your master surface, and your your deformable body will act as your slave surface, because a rigid body will have a larger stiffness and deformable body will have a smaller stiffness. So that is, in this way we have modeled the superstructure in Abaqus. Now next part is your pile modeling. So because in today's class I have taken pile modeling only. So in piles, basically there are two different types of pile. One is end socketed pile and there is floating pile. Before coming to this one, as per Indian code, what they used to say that each column should be supported over minimum number of 3 piles. So just imagine, suppose if I am having here, you can see at the bottom there are total number of 9 columns. If suppose 9 columns are there and each column I am having 3 piles. So total number of piles, how many I have to model? That is 27 number of piles. If you are going with a multi-rise buildings, high-rise buildings, like for 20-story buildings, which the results of which we are going to discuss in this webinar. So for a 20-story building, suppose I am saying, so in that case, number of columns will be more. So it may be 25 number of columns. So for a 25 number of columns, there will be minimum 75 piles should be there. So larger number of piles are there, your computational time will again increase drastically. So for that, to reduce the computational time, what we have done, we have used the equivalent pile approach defined by Paulus. So for that, for an end socketed condition, the equivalent, the equivalent diameter of the pile is obtained using this equation, and for a floating pile, the equivalent diameter is obtained using this. So what we have done, that you can see in the slide also. So this is, suppose this is basically your 3 pile system is there. So depending on, we have taken the gross area, and corresponding to this, we have made this one as a single pile, and the diameter has been obtained using this equation, depending on end socketed condition and floating condition. Because in Mexico City airport, it was observed that the floating pile buildings are more damaged in comparison to end socketed condition. So what is the reason behind that? That is also being investigated in the study. Another thing is, whenever you are doing, because this one point will be coming in the mind, that if we are doing this kind of study, basically what we are doing, we are avoiding the shadowing effect. So for that, to avoid this one, we have taken equivalent Young's modulus also. So equivalent Young's modulus has been obtained from this equation. So these two properties which we have taken for pile modeling, and we have modeled like this one. Now one more thing, whenever we are doing any pile modeling, we should know there are several things, like we want to know the bending moment, we want to know the shear force, we want to know the lateral deformation. Now this is the disadvantage, if we can say, or there are several ways by which we can do this modeling in Abaqus. You can use a wire element, you can use a solid element, but with each type of modeling, there are certain disadvantages involved. Like if suppose I am using a beam element, so if you are using a beam element, what will happen? Obviously, if I am using a beam element instead of this solid element, what will happen? Obviously, number of elements will be less. Then obviously what will happen? If number of elements are very less, then obviously what will happen? Your computational time will reduce. But in that case, there is another problem, because the piles which is surrounded by soil, here what will happen? There are frictional resistance offered by the soil from the surrounding soil. Then there are end bearing resistance that cannot be modeled when I am using a beam element. Okay, so if I am using a beam element, this is the benefit and this is the disadvantage. Another benefit with beam element is what? If I am using beam element, I can easily find the bending moment, shear force, lateral deformation, everything. But we cannot simulate the interaction between the surrounding soil and the pile. Now, so to overcome this, we will use solid pile. So if I am using solid pile, now I can simulate the tangential, means this frictional forces which is being surrounded by the outer soil, and your end bearing resistance also. But in this case, the problem is Abaqus does not provide bending moments and shear force for a solid pile. So how we will obtain the bending moment? So there are two ways. Either what you can do, you can obtain the lateral deformation, and then you can do the integration, and then you can find this one. So to overcome this one, there is a technique in which what we used to do, we will use this combination of beam element and volume element. So in this one, what we so I have used so what we are doing, so overcome this one, we are modeling the pile foundation as a volume element, and to find the bending moment and other thing, we are using a beam element. This beam element, what we will do, we will embed this one in this solid pile. So for that, what we need axial stiffness, sorry, axial rigidity and flexural rigidity. So that we will assign, so that your pile means you can simulate the interaction, that is the frictional forces and end bearing resistance, and you can also get the bending moment. So for that, I'm using this element. For volume element, volume pile, I'm using this one. So if once we have done the modeling, you will see this one. So you can see the outer one is basically your volume pile, and to estimate the bending moment and other things, we have embedded a beam element inside this one. And the beam element properties are, this is the axial stiff rigidity and flexural rigidity of the embedded beam has been assigned, so that this embedded beam is also deforming similar to the pile only. So in this way, we have done the modeling of pile in Abaqus. So this is the pile modeling you can see. Another thing is that, which might be coming in your mind, that uh, how a pile foundation modeling will be different from your pile raft. So that we will see in the upcoming slide, that how that modeling has been ensured, that how I have ensured that these piles are behaving, means these caps are not taking any load, because in pile raft we know a small amount of load, basically amount of load will be taken by raft and another amount of load will be taken by piles. But in case of pile foundation, all the loads are generally taken by piles only. So how this action has been ensured in Abaqus, that also we will see in the upcoming slide. Now another point is, whenever I am doing the soil modeling, so we know what is the common methodology is that we will use constant Young modulus, we will use constant Young's modulus values, but we won't consider the dynamic characteristics. But in actual condition, whenever an earthquake is coming, depending on the characteristics of your earthquake, the strain level will be different, and depending on the strain level, there will be degradation in your soil, means difference degradation will be there, and its damping ratio will also change. So we should consider, that is basically the non-linear characteristic of our soil. So whenever you are doing any dynamic study related to soil, we should consider this shear modulus degradation curve, and we should consider the damping degradation, that is basically with respect damping variation with respect to cyclic shear strain. So for that, we have developed the UMAT model, and this is the different parameters which I have used. So depending on which the non-linear characteristics of the soil has been incorporated in Abaqus. Also, proper calibration has been done before using this soil model for my study also. Now, 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 as I mentioned that we are using a dynamic study. So for that, I have taken these 4 different types of earthquake. Basically, today in today's class, we are going to discuss on Imperial Valley earthquake only. One more thing, whenever you are doing any kind of study on Abaqus, one should ensure that whichever earthquake data you are using, it should be recorded at bedrock level, not at the soil level. Because if you are recording, if you are taking any data which is recorded at the soil level, it will be already amplified. So in order to do that one, what you need to do, if suppose you have got a data from soil level only, so then you need to perform deconvolution, and then you will get the raw data. So these all data have been obtained from PIR. PIR is basically an strong data motion database where you can get these data. So basically, we have taken these 4 different data, that is your Imperial Valley, Chichi earthquake, Tohoku earthquake, and Kobe earthquake. Why I have taken these 4 earthquakes? What you can see, because there are several parameters, that is intensity, your duration, your hypocentral distance, your magnitude. So these are different things which will affect your seismic performance of a building. So depending on that, we have taken this thing. Another thing is that, because if I'm providing all this duration, obviously it will take so much of time. So instead of that, there are 2 things which you can do. Either you can provide significant duration in Abaqus, or you can provide bracketed duration in Abaqus. So in my study, I have used bracketed duration. What is bracketed duration? So bracketed duration is the time interval between the first and last exceedance of the acceleration time history. Means what we will do, we will plot the acceleration time history from the uh, the outcropping rock motion we will take, and then we will see first time where the earthquake intensity 0.05 g, and where it is at the last. That complete data we will take, and that data will then is generally known as bracketed duration. So in our study we are taking bracketed duration. Now, whenever we are doing any modeling in Abaqus, so now we understood that okay, I will create different parts. I will create a foundation. I will create a structure. I will create a structure. Sorry, soil. Now, another thing is that how we will decide how we will decide that the interface, like in structure I shown you that okay, interface will be done between yours by providing a tie constraint. But in case of piles and surrounding soil, a frictional force is there and an end bearing resistance is there. So for that, what is the ideal characteristics? Ideal characteristics is that when separation is zero, there should be no contact pressure. But as soon as there is no separation, means this pile is touching. Just keep in mind this is the microscopic level we are showing here. So that is why you are seeing the gap here. But there is no gap. But there is no gap available here. So what basically is the ideal characteristics? When suppose you are applying the load, so automatically what will happen? There is no separation. So there should be contact pressure should be maximum. But in actual condition, we can't get the ideal characteristics. So for that, what we will do, we are using this characteristic which is available in Abaqus. And this characteristic is basically known as hard surface to surface contact. So in this one, since my pile is having larger stiffness, so that is basically rigid means larger stiffness than soil. So that is why pile is acting as a your master surface and soil is acting as a slave surface. So in this one, to simulate the frictional forces and the end bearing resistance, we will provide hard surface to surface contact using normal interaction, and using for frictional behavior we will follow your tangential interaction, in which we will use penalty method that is available in Abaqus, and there we will provide the friction coefficient, details of which is again given in my paper, which I have mentioned there in the that previously. Again, the details of the paper is coming in the last slide of this presentation, so there you can get that also. Now, so this is the complete modeling which I mentioned here. So first thing what you can see, so as I mentioned, whenever we are doing any kind of soil model, we should ensure that the soil is infinite. So for that, in the direction of shaking, we have provided infinite element, that is CIN 3D8, and then your pile and this soil, we are providing the interaction as normal and tangential interaction. One more thing, if you will see clearly here, what you can see here, this pile cap is above the ground. If we are keeping it above the ground, obviously what will happen, because of what is the major function of a foundation, that is to transfer the load to the surrounding soil. So since this pile cap is above the ground, it won't transfer any load. So if it is not transferring any load, all the loads will be taken by the pile. So in this way, the simulation of pile foundation has been taken care of during the modeling. Now another thing is, what are the boundary conditions? So boundary conditions is in the direction of shaking, that we can understand from the 3D slides also. This is the 3D model. So you can see here, in the direction of shaking, we are providing infinite element. Bottom has been fixed. This 3D slide is basically for end socketed condition. Now, in this direction and in the opposite direction, your out of plane rotation has been not allowed. One more thing, which is the major mistake people used to do whenever they are doing any soil modeling, what they used to do is that they do not consider they used to use the default view of Abaqus. So if you are using default view of Abaqus, then the depth will be in y direction. But what we should do whenever we are doing any modeling, this should be the global XYZ axis. So depth should be in that direction. And once you have assigned the boundary condition, you need to provide your geostatic stress. Geostatic stress is what? In initial condition, how your soil condition will be there. So that you need to assign. That will be provided here. So this is the 3D model which we have developed. Now, another point, whenever we are doing any kind of numerical modeling. So far we have understood that these are the different contexts we need to provide, different properties we need to provide, different boundary condition we need to provide. Another thing which will influence your computational time is your meshing. So you should perform mesh convergence study. But before mesh convergence study, because this is a dynamic problem, so for that there is a criteria that is Lismer boundary condition, Coulomber-Lismer boundary condition, corresponding to which we should ensure the wavelength, like what is the mesh size which I am using. This should be ensured corresponding to the wavelength of your seismic wave. After that, suppose you have obtained your mesh size. So corresponding to that, you should perform mesh convergence study, and you should see, like in my case, the major parameter is natural frequency or time period. So what we will see, like you can see here, like for a fine mesh of 0.7 and very fine mesh of 0.25, the natural frequency for a fixed base is nearly same. So why to go with very fine mesh? Because if I am going with very fine mesh, my computational time will be very high. So instead of that one, we will go with a fine mesh. Similarly, for SSI model, you can see for a very fine, it is 0.5. Nearly natural frequency are nearly same, because FEM, it can't give you accurate result. We don't want very accurate result. We want precise result. Means error should be less. So error should be less. Your optimization should be in such a way that the error is less and your computational time is also not more. It shouldn't like it shouldn't take more than, like, if your analysis is taking 1 month, 2 months, then it is of no use. So that is why we should perform mesh convergence study. Another thing, whenever you are doing any kind of seismic study, is the radiation damping. So radiation damping, for that, what you can see here, that in this model we are only providing the infinite element in the direction of shaking also. So it might be in your mind that why you are not providing infinite element all the sides. You can provide, but again, what will happen? Your computational time will increase. So you can see we have done this trial also, where we have gone with the infinite element in all the direction and infinite element in the direction of shaking also. So here you can see, although the results is very less, I mean difference is 4.10%, but computational time, like for this analysis, it took for me, for in this analysis, it took around for this one, it was taking more than 4 days, 5 days. This I am getting in 2 days only. So instead of this one, I will use this one only, because error percentage is less only. So that is why I have used infinite element in the direction of shaking only. So in this way, you can create a model in Abaqus. Now, once you have created your model, you should know what are your steps. So those steps are, so firstly, you should ensure your geostatic condition, that is your K0 condition is satisfied or not. Once your K0 condition has been satisfied, before moving to the dynamic condition, we should go with static condition. In static condition, what we will do, we will assign the weight of soil, we will assign the weight of foundation and weight of the structure. That is basically applied. And then in the intermediate step, in this case, one more thing, when you are using the static step, first step after geostatic step, just keep in mind, don't assign the frictional coefficient value to your soil, because until unless there is no load is applied, if no external load is applied, no friction will come into picture between foundation and soil. So that is why in initial condition, frictionless boundary condition should be there. And then you should have define another step, that is your intermediate step. In intermediate step, you will assign the frictional behavior, and in which you will assign your all your dead load, your live load, whichever your thing is there, that we can assign here. And then in next step, we should define a frequency step for finding the mode shapes and natural frequency. And then in the last step, you can go with dynamic step. Now, on the another thing, what you can see here, that is implicit motion. What is this implicit motion? Because in study, in Abaqus, it will provide you two types of study. One is dynamic implicit, another is dynamic explicit. But in this one, we are using dynamic implicit only. So what is the difference between them? If the independent variable can, mathematically, if we will say, if independent variable and dependent variable cannot be separated from each other, then those functions are known as implicit functions. In this one, basically, we used to follow iterative procedure to obtain the solution by following Newmark beta method. So that is the details of dynamic implicit. So these are the different steps which I have used and how we have created the model in Abaqus. After that, there are different structural characteristics. In today's class, we are in the webinar, I am using the results for a 20-story 4-bay building, and these all buildings are found to be under safe condition as per the Indian codal provisions. Depending on different load combinations, we have taken a grade concrete of M50 and thickness of slab is 150 mm. And for foundation characteristics, basically what we have done for finding the foundation, what we have done, we have taken the unfactored load from unfactored load. Corresponding to that, we have obtained the column reactions, and then what we have done, we have taken this end socketed condition and floating pipe. Now for that, now one more thing which I forgot to mention, like there is a common myth that if suppose people want to say, like if common people, if I will say that I want to improve the performance of my structure, what they will say, increase the length of the pile. But always increasing the length of the pile may not be a proper solution. In case of floating pile, that is observed also in my results also. So that is why we should see whether till means whether we should provide a larger length or not. That is why we are mentioning that the coupled study should be performed. Now, another thing which I mentioned is whenever we are doing any nonlinear study, means whenever we are doing any kind of study, whether it is industry purpose or whether it is for a academic purpose, we should consider the nonlinear characteristics. And what is the another good thing is that the if you would have seen the new codal provisions of IS 1893, that is the draft one which has come, there they have given this modulus reduction curve and damping curves, that is basically taken from Bukittig et Dobry. This is the results of my own data, that is Sunani River sand I have taken, sandy soil I have used. The details can be obtained in this paper, which is already published in Geotechnical and Geological Engineering. So so important thing is that in our code also now people now the this data are also being included. So now they have been using Bucketing and Dobry curve in this one. For the corresponding different plasticity, they have given how the shear modulus reduction curve and damping curve will vary. So that they have given there. So corresponding to these characteristics and foundation characteristics and structural characteristics, we have done the model which I have shown you previously, and then we obtain the results. So you can see how the mode shapes of the building are varying. Although from directly from here, what you can see here that if you will see the mode shape, that is the first mode shape, that the deformation, if you are keeping a what do you say the a reference line, if I'm plotting a reference line in this direction, what you can see here, that was a this corresponding to this line, if you will see something like this is the displacement. But in this one, if you will see corresponding to this deformation, automatically you can see what has happened. This deformation is larger than the above one. The region can be can be understand from the previous first slide where I shown you that, because what is happening now, this foundation is basically what this foundation is doing. This foundation is basically doing rocking, means it will tilt like this one. Due to this tilting, automatically what will happen, the deformation of the building will increase, which can be observed from the time period results also. So you can see for a fixed base, you can see what is the time period. The time period is 1.446 seconds. But as soon as I am using a foundation, which any foundation, L by D 30, 60, 80, whichever foundation system I am saying, whatever foundation system you are saying, what you can see, there is increment in the time period. So as I mentioned, that during Mexican City earthquake, during Kobe earthquake, period lengthening takes place. So if I am using this equation, T is equal to 0.075 h raised to the power 3 by 4, I will get a value near y to this one. But in actual condition, the time period is this one. So just imagine, suppose an earthquake is coming, and the fundamental period, that is the period of that motion, lies in this seconds. So what will happen? There is a chances of resonance. So if resonance is there, what will happen? Because we have designed a structure corresponding to this data. But in actual condition, the building's time period is this one. Fundamental time period is this one. So there are chances that because if fundamental time period is increased, means natural frequency is reduced. So if natural frequency is reducing, means what will happen? Now you see what are the different parameters, what will happen. So what we are doing in fixed base, we are using how we are designing a structure. We are designing the structure corresponding to base shear. So what will happen? Like suppose I have said for this, the base shear is, suppose I am saying X kilonewton. We have designed for X kilonewton without considering the effect of foundation and structure. But in actual condition, when this coupled system is coming, this base shear is reduced. It may be Y kilonewton, and this Y will be very, very less than X. And this methodology is being given ASC also. In ASC 716, if I correctly remember the chapter, I think chapter number 20 or 21 is SSI. There you will see, there they have given that we should not use the base shear which is directly obtained. Like we used to say V is equal to AH into W, that is seismic weight and the acceleration coefficient. In this one, we are not considering the effect of structure and the coupled system. That is why they are saying we should modify this one, and we should design the structure corresponding to the modified base shear. So this is the importance of SSI whenever I am doing. So why these all things are phenomena is occurring. One other thing, what you can see here, when I'm increasing the length, of the pile, you can see reduction in time period. So why the reduction is there? Obviously, the larger the length will be there, greater will be the resistance offered from the surrounding soil. So what will happen? Obviously, overall stiffness will be increased. If overall stiffness is increasing, what will happen? Your rocking will reduce. If rocking is reducing, performance of the structure will increase. That is why if slenderness ratio of piles are increasing, the performance of the structure is increased more. This can be observed from the results for floating pile and socketed pile. Now, what you can see here, in case of floating pile, what you can see here, what which I was mentioning previously also, when I'm increasing, this is a common thing. What we used to say that if you are increasing length of pile, your lateral displacement building will be more safe. But what you can observe here is that lateral deformation in case of floating pile is still increasing till a particular value of L by D equal to 60. But beyond that, it is reduced. So that is why just by putting blindness, we should not increase the length of pile. Why this phenomenon is occurring? Because of the flexibility. Because in floating pile, there will be no end bearing, means end bearing resistance will be there, but it will not be that much higher in comparison like we will get in case of end socketed pile. So that is why if you will see here in this case, end socketed pile frictional resistance is also more and end resistance is also very high. So that is why the deformation of building is very less. But it is very tough to obtain a rock wherever you are constructing a structure. So that is why whenever you are using floating pile, you should consider the effect of SSI. This can be understood from one more slide. This is rocking, which I was mentioning previously. So what you can see here, that in floating pile, the total, like I am mentioning this lateral displacement, 317 mm. From this 317 mm, about 58% has been caused due to the rocking of foundation. So that we are not considering while designing any structure. So this is the reason why the buildings were collapsed during Mexican City earthquake, during Kobe earthquake, because we are generally not considering the effect of SSI while designing it. So that is why we should consider the effect of SSI whenever you are doing any kind of study, specifically for your what do I say, for your high-rise structures or the soil where that is of classification D and E and F. So in all those cases, we should consider the effect of SSI because the performance of the structure will be significantly changed, and it may. So what will happen? It will also affect the surrounding structures also. So that is why SSI is important, and in this way you can do the modeling in Abaqus. And this is the conclusion which I have already discussed. So for more details, like I have given only if someone is more if someone wants to know more about the numerical modeling, they can go with this paper number 4. And another paper is about to come. This is in earthquake engineering and engineering vibration. That is basically for shallow foundation. This is basically for a pile foundation. The remaining other papers are basically on how I have, as I mentioned, that I have also performed experimental investigation. So if you want to go for this one, then you can go with other papers also to learn regarding how soil foundation and structure interaction will play an important role in your seismic design, so that you can get from these publications of mine. And these are by different book chapters also. And so these are the different details which you can obtain. And uh, also I would like to acknowledge the Mayank and Mayank Panchal and PIGSO Learning for giving me an opportunity to present my work and this small webinar on this SSI, that how to do a modeling and all. And also I want to thank my supervisors, Dr. Monaji Samanta and Dr. Devi Prasanna Kanungo, those, those who have given proper guidance and mentorship during this complete my PhD work, which I have done previously from Central Building Research Institute, Roorkee, and Dr. CBRI Roorkee also, to provide all these facilities for experimental facilities and numerical investigations. So, so that I'm in a position today that I can make you understand that how Abaqus is working and how this all things are working. So you can, these are these are the peoples I want to acknowledge today. So thank you. And these are the contact details and other things which you can contact for more further details. Thank you.
Thank you, Dr. Vaibhav Mittal, for an excellent and informative presentation. We truly appreciate you for sharing your expertise with us today. I
Thank you.
hope,
Yeah.
yes, I hope everyone found the session valuable and gained some new insights into using Abacus for geotechnical analysis. Before we wrap up, I would like to remind you for a few things. Like, we have an upcoming training programs. For that, you can check our website for more information on upcoming courses and training programs. We provide project assistance also. If you have a specific project and you need help with, please don't hesitate to reach out to us. We offer personalized project assistance to help you to achieve your goals. And at last, please take a moment to complete the short survey that will appear at the end of this webinar. as we value your feedback and your input will help us to improve our futures events.
I think Utkarsha, I think one student is having some doubt. Can we take
Okay.
any doubt, anything? If anyone is having any message or any doubt
Yeah,
or two
just
doubts, yeah. If any doubt, anyone can take 5 minutes.
okay.
Yeah. Yeah, Ashish, I think you are having cert. Once you have raise your hand, you can unmute and you can tell if any doubt. We can take 2 to 3 doubts. Remaining other doubts you can contact directly to the email ID which is already provided in the chat box. Yeah, Ashish, you can type. You have raised your hand. Any doubt to anyone? They can ask if anything before we complete this lecture. Yeah, Ashish, we can't hear you. And it's okay. Ashish, either you can type in the chat box. We can see if any doubts are there. Any detail if you want to ask. A few persons are raising their hands. Ashish and Srivaksa are raising.
Uh,
Okay.
if anyone is having doubt, please put in the chat box.
Shiva, what Utkarsha, can you unmute them? I think they can't unmute themselves, or we can they can just type
Yeah,
them. Yeah,
just a moment. Yes.
sure. Okay. Yeah. Yes, Ashish. Now I think you can say. Yeah.
Yes, sir. Am I audible, sir?
Yeah, you are audible.
Okay, so first thing that you in the previous in the upcoming slides, in the starting of the slides, you mentioned that you have used the two elements like solid elements as well as the beam elements,
Right.
just to model the interaction behavior as well as to find out the bending moment and the shear force along the pipe. Is
Right.
it?
Right.
So then, sir, what I want to ask that, like you were saying that the solid element is embedded into the beam element.
Right.
Okay. But you
In
were saying that
yeah.
in a beam element, you cannot give the interaction behavior. Although you are providing a solid element inside the beam element, so the solid element will not be in the touch of the soil, surrounding
No,
soil.
no,
So
no, no,
how you can define
no,
the structure?
no, 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 no,
Sorry, sir.
no, no. Beam element is basically embedded inside the solid element. Solid element is not embedded in the beam element. Okay.
Okay, sir.
Uh,
If you are saying that a beam element is embedded inside the solid element,
right.
even though will it give the correct bending moment and the shear force diagram along the pile length?
Yeah. So that is why for ensuring that to get a proper bending moment and shear force, that is why only we have given, as I mentioned, we need to provide two things, that is axial rigidity and flexural rigidity, that we need to estimate from our actual pile, and that we need to assign to that beam element also. So then only you can get the correct estimation of that bending moment and shear force. Otherwise you can't get, just by assigning the beam element and by giving its diameter we can't get. We should assign the axial rigidity and axial stiffness and your flexural stiffness, then only you can get these two values. Okay.
Okay, sir. Thank you. And one more question, sir.
Yeah.
Like you said that in a static condition, when you are modeling, then
Yeah.
at that time you do not have to provide the interaction behaviors like normal and tangential behavior. Is it, sir?
No.
Because
What
you are saying that,
yeah.
sir, you were saying that no external load is applied. So at that time, we don't need to give the interaction behavior at that time. Okay, in the static condition.
Okay. What I mentioned that because means frictional behavior will come into picture, right? So what
Okay,
I
sir.
mentioned that when there is no external load, then in those cases we should not assign frictional frictional interaction property. We should use frictionless interaction property. Means we will use normal and tangential interaction, but in tangential interaction, instead of using penalty method, we will use smooth. Means we will use smooth or frictionless interaction. But once external loading is coming, then in that case, in tangential behavior, we will use penalty method to assign the friction coefficient. Okay.
But sir, if we think that if you are modeling a proper, let's suppose that a field condition, let's suppose the building, high-rise building is there, and you are modeling pile and high-rise building.
Right.
In that case, whatever the load is coming because of the superstructure, that will also be encountered through the end bearing as well as the frictional behavior, na?
Right.
So at that time you have to use the both interaction, but you are considering only the end bearing. That is the
No,
normal behavior, but you are not modeling the tangential behavior.
no,
Don't you think?
no, no. What I mentioned that initially in the first step, when a static loading is there, in that case, what we are doing, just we are assigning the weight. In the first step, when we are assigning the weight, then in that case, only the self weight of the structure will be there. So what will happen if you are only assigning the self weight? Then in those case, there will be no deformation occurring in the due to the self weight of the structure of the foundation. So in that case, what will happen? No frictional behavior will come into picture. So that is why in that case, I'm mentioning that you should not assign frictionless interaction once only when you are assigning the weight. And once you are assigning all these load, like your live load, your dead load, whatever kind of load for wall loads, whatever there, then that is why you need to assign a second intermediate step. In the intermediate step, you should assign the frictional property also. Okay.
Okay, sir. You mean that first of all, we have to provide an intermediate step in that we have to give in the
Yeah.
these both interaction behavior. Okay, sir. Okay, thank you, sir. Thank
Okay.
you very much.
Okay. Okay. Yeah. I think Utkarsha, I think we can sum up this.
Okay.
Yeah.
Yes. So thank you all. Thank you all for attending. We hope you found this webinar beneficial, and we will be sending out a recording of the session to all attendees shortly. Have a great day, and we look forward to connecting with you at our next event. I have mentioned email ID, contact number, and website in chat box. So, and at last, please take a moment to complete the short survey that will appear at the end of this webinar. So, we value your feedback, and thank you. Thank you all. Thank you, Dr. Webb of Mittal.
Thank you, Utkarsha. Thank you. Thank you everyone for joining the webinar. Thank you.
Yes.